Hi everyone, we're going to talk about the basics of evaluating functions in this video. So notice that I already have a function written on this screen. F of x equals x cubed plus x squared minus 2. And so we're going to evaluate at different expressions. So the first one I want to evaluate is at f of 3. So what I tell my students is that everywhere you see a variable, you should put a parentheses. So here I have an x, so I should put a parentheses. Then the cube, the exponent, goes outside the parentheses. Plus, and again I have another x, so I'll put another set of parentheses. The squared, again, will go outside those parentheses. And then the minus 2 doesn't have any x's, so it just comes along for the ride. And so this is what I tell my students. When you're trying to evaluate a function, you take what's ever in this parentheses and insert it into what's in these parentheses. So since there's a 3 here, we're going to put a 3 here and a 3 here, and then we simplify this. So in this case, 3 cubed, if you did not know, is 27. Then we get 3 squared, which is going to give me a plus 9, and a minus 2 comes along for the ride. And then we simplify it, so we're going to get a 27 plus 9, which is a 36. Minus a 2 comes along for the ride, and we get that the answer is 34. That's nice and all. So let's try a little different number here. So I'm going to erase all this, since you can stop and copy this at any time. And we're going to put in a new number. So let's try -1. So again, you should do the same thing as before. Everywhere you see a x, you should put in a parenthesis. So we have an x here, we're going to put in a parenthesis, and then this exponent just comes along for the ride. Plus, then we're going to have this x turn into a parenthesis, and then this 2 just comes outside here like this, and then this minus 2 doesn't do anything, it just stays there. And then, just like with our previous example, this -1 is going to get inserted in both of these parentheses. And here, this is the first example where the parentheses really help you, because this keeps tracks of the signs. For example, -1 squared, so this is just a little bit of side work to illustrate why you need the parentheses, is not the same as -1 squared. Because the order of operations on this side say square the 1 first, so we'll get a 1, and then the negative applies and you get -1. While on this side, this says that this is just -1 times -1 by the definition of what square is. And I just almost opened my weather app, sorry. And this will equal a +1. So notice that these parentheses help with sign errors. So it's very important that you use them when you're doing substitutions. And then we can just finish our simplification, and this -1 all cubed will give us a -1. This -1 squared will give us a +1. Then the -2 comes along for a ride, and the -1 and the +1 cancel, and this just leaves us with -2. Now, again, I'm going to erase everything and do one more example. And one thing, this is the part that really confuses people, is that we can not only substitute x with values of numbers, we can substitute x with other expressions in x. And the technique is very much the same. So if you've got this technique down from these last 2 examples, it is not hard to extrapolate it to the next example. So let me erase all this really fast. I guess I'm drawing out erasing, so let me hit the right button on my pen. So we'll delete that, get all that, and delete that. And here this time, instead of a number, I'm going to put in an expression x plus 1. So again, the same rule applies as we do when we're substituting numbers. Everywhere we see an x, we are going to put a parentheses. So here, I'm going to put a parentheses in for this x. This cube goes in the outside, plus, then I'm going to put a parentheses in for that x, and then this square comes along for the right, and then the minus 2 just comes along as before. Now, instead of plugging in a number in the parentheses, we're going to take what's inside this parentheses and plug it into both spots here. So in this case, we're going to get an x plus 1 and an x plus 1. Now, both of these expressions are easy to multiply out. You can either just FOIL it out, or both the expressions x plus 1 all cubed and x plus 1 all squared can be written out using the binomial theorem, which is what I'm going to do since it's faster. So it's going to be x cubed plus 3x squared plus 3x plus 1. So this is the part that is x plus 1 all squared. Plus, and then x plus 1 squared is just our normal perfect square formula. X squared plus 2x plus 1. So this part here is the, oh, I miswrote that. That should be a 3. So over here is the x plus 1 all squared. And then the minus 2 just comes along for the ride. And then all we have to do now is combine like terms. So there's only one x cubed. So I'm going to, I usually mark these off. So I have used that term. We have 3x squared and an x squared. So I'm going to combine those and get a 4x squared. And we'll mark those off now. That is being completed. We have a 3x and a 2x. A 3x and a 2x, and that's going to give us a 5x. So we'll have a plus 5x. Then we have a plus 1, and a minus 2. And it's nice that all cancels. So this turns out to be our expression right here. The only thing you could do is factor out an x, but that's really not necessary. This is just as nice as form as any. So once you have these skills and have them practiced, then you're ready to move on to the last topic in this section, which will be the subject of our next video, difference quotients.